Limiting factors of photosynthesis, flip learning clip. Okay, so in today's lesson we're going to be looking again at photosynthesis. I'm going to do a very quick review now of what photosynthesis is. So what I'd like you to do is write down the balanced symbol equation for photosynthesis. Stop the clip now and see if you can do that. Okay, so hopefully you've all done that. And this is what you should have got. You should have come up with the fact that we have 6 carbon dioxide molecules. Alright, 6 water molecules, 1 glucose and 6 oxygen molecules being made. Alright, if you don't know that, if you couldn't do that, you must revise it. It's a really important part. Photosynthesis is a massive section of B2 and they could ask you about this at any point or anything that links into it. It also links into respiration, so make sure you know this. Alright, so a quick question for you then. Why do plants grow quicker in the summer than in the winter? Alright, so one of the most obvious factors, one of the most obvious things that happens is that we have more light during summer. Okay? And with that light generally comes warmth. Okay? So we've got much more light, we're warmer. Okay? Now there is one other factor that affects photosynthesis, but it doesn't change particularly regardless of whether it's summer or winter, and that's the amount of carbon dioxide. Okay, so these 3 things are limiting factors. Basically, a limiting factor is anything that will limit the amount of photosynthesis a plant can manage. So we've just said our 3 limiting factors are warmth, so temperature, light, or we're going to call it light intensity in a short while, and carbon dioxide, the levels of carbon dioxide. So if we first look at light intensity, there's a really nice little practical that we can do. Doesn't always work, it's not always brilliant, but if we put together a lamp and we put it on a meter ruler, put some pondweed into a beaker and into some water, and what we'll see happening is that there's bubbles being produced. Now those bubbles are oxygen. It's that waste product that they're getting rid of. And pondweed is particularly good because we can actually see the oxygen being produced. We don't see oxygen coming off the plants that are normally around us. Okay, so we put it at 10 centimetres. Okay. And we count the number of bubbles that are being produced. And then we move it away to 20 centimetres. Do the same, count the number of bubbles, then 30, 40 and 50. Okay, we can do it further if we want, but generally after about 50 centimetres it stops working anyway. So what we've done then is we've had different light intensities, so the closer the light is, the more intense it is, and as we've got further away we've gradually reduced the light intensity. So if we look at the graph, what we can see is as we increase the light intensity, so as we get closer to it, so we're getting closer, we can see that the rate of photosynthesis increases. And what eventually happens, and it's just happening here, so it's slowed down here, it's still increasing, and here it levels out. Now we do eventually get to a point where no matter how bright the light, no matter how sunny the day is, the rate of photosynthesis is going to stay the same. Okay? Because at this point light is no longer the limiting factor. It's not light that's slowing it down, there's something else. So the other things that could be slowing it down are the temperature and the amount of carbon dioxide. So let's look at those then. Alright, so temperature. So why does temperature affect photosynthesis? So we can see with temperature that initially the rate increases. Alright, and then we reach this peak. And after this peak, the rate decreases, and really quite rapidly. Now that peak usually is around 40 degrees Celsius. Okay? Now, it peaks at that temperature because photosynthesis is a chemical reaction, and temperature affects all chemical reactions. So we know from in the past when we've looked at rates of reaction that the warmer something is, the faster the rate of reaction. Now, photosynthesis works in the same way until we get to that 40 degrees, because photosynthesis relies on something called enzymes. Enzymes are essential for carrying out photosynthesis. once we get to 40 degrees, those enzymes basically get destroyed, and we'll look in more detail at enzymes in a short while. Now, enzymes, the fancy term for it is enzymes become denatured. So, why does temperature affect the rate of photosynthesis? Well, it's a... Oh, I didn't want that. Sorry guys, let me just get rid of that. That was my jacket on there. So, it's a chemical reaction. Okay. So it speeds up with heat. Right. Until we get to this critical point, the enzymes denature. And that happens at around 40 degrees Celsius. Some plants are higher. It can go as high as 50. But as far as we're concerned, that golden number for now is 40 degrees Celsius. So, the warmer we get, the faster the reaction, until we hit that critical point of around 40 degrees Celsius, and then we drop back down. Alright? So our last limiting factor is carbon dioxide. So you'll see this graph looks really similar to the graph that we had about light intensity. So carbon dioxide is needed to be able to make the glucose. It's one of the raw materials. It's one of the reactants. So it's a reactant. Alright, so really important. We need it. Otherwise, there's no photosynthesis happening. But actually, only about 0.04% of the atmosphere, no, need a rubber, atmosphere is CO2. Okay, so there's not a lot of it about. Now, because of the low levels of carbon dioxide in our atmosphere, it actually tends to be the most limiting factor. It's the one that tends to slow it down. So if you think about it, on a nice warm sunny day, you've got plenty of sunlight, it's a lovely temperature for photosynthesis to be happening at, but there's still only 0.04% of carbon dioxide. Alright, now although we say that, there does tend to be a difference between day and night. During the day, the amount of CO2 is low, and at night, amount of CO2 is actually higher. Now, can anybody hazard a guess as to why that would be? Well, the reason for it is that when plants create glucose, they need that to be able to do several things. They need it for energy, so they need it for respiration, and they also need it for growth and for making things like starch. They use that glucose, they store it, and they do different bits and pieces, and we'll look at that. We'll carry out a practical on that in another lesson. At night, they're not photosynthesizing at the same rate, so they're not taking in and using up that carbon dioxide. They've just got carbon dioxide to get rid of from respiration. So actually at night, the amount of carbon dioxide around them can be higher. Alright, so we now know that there's 3 ways that photosynthesis can be limited. So now we've got that knowledge, we can use that knowledge. Scientists do use that knowledge to help us grow more food. So anybody out there that knows any farmers or is a farmer, okay, we have various different things on this diagram. Now you can pause the clip if you want and try to find out what they are, try to identify them, but I'm going to carry on. So we've got lights, so that we can produce as much light as we want, so even at night there's still lights. We have a heater here, so that we can maintain the temperature. Okay, so we can keep that nice and high. And on top of that, we also have these vents, so that if the temperature gets too high and there's a chance that those enzymes are going to get denatured, we can actually open that vent and we can allow the heat out. Okay, so we can maintain our temperatures. Alright, we've also got blinds, again, help us maintain the temperature. But here's the other bit. Here's the bit that we said that we have the most trouble with being able to look after. Oh, no. Got it on the wrong thing. Sorry about that, guys. The thing that we have the most trouble with is the levels of carbon dioxide. So if we look over here, we actually have a burner, a propane burner. And that produces carbon dioxide, as does this. This produces carbon dioxide because combustion creates carbon dioxide. So we have something that's pretty cool. We have a way that traps heat. We've got lights. We can release heat when needed. Okay. We can create heat when needed. And we have a method of creating carbon dioxide. Now, just for you guys, in case you were wondering, that goes round and in through this system. Right, so there are plenty of ways that we can actually help us grow more food. So we're getting rid of those limiting factors. Now, farmers don't tend to use greenhouses. You'll see them using polytunnels. So for those of them that grow vegetables, you don't only want to be growing tomatoes at very short times of year, because then the rest of your land lies without anything to do on it or the rest of the year. Okay, so polytunnels are very popular, but what's becoming even more popular is this thing called hydroponics. Now, hydroponics works very differently to what we've seen before in terms of there is no soil. In here, they're actually sat, all of this is a liquid. Okay, and it's a liquid that goes in through here. Okay, should be using a pen really. Okay, liquid that goes in through here, up and in and through, and that liquid has an absolute perfect balance of mineral ions instead of soil. So all the minerals and things that it needs from the soil, it gets it from the water. So we've removed any sort of limiting factors. It's got perfect balance of mineral ions. In there we've got a computer system that tells it when it needs water, doesn't need water. Okay, and remember it's sat in water. It's telling them what temperature is, if it needs more carbon dioxide, if it's too hot, too cold, and it all works on a computer system. So the actual yield is massive, and they start to save or make an awful lot of money. Okay, so it makes a lot of money because your turnover is so fast, and it's the same with the polytunnels. Your turnover is incredibly fast. It takes a lot of energy to keep these conditions in the greenhouses just right, but on the plus side, fewer staff are actually needed. Alright, we are starting to get to the point where limiting factors are becoming a thing of the past, and that's a pretty major thing to be able to say, especially in a world where we have so many people that don't have enough food and can't afford their food. And things like vegetables, people say they can't afford them and that fast food's cheaper. Well, hopefully this will go some way to eradicating that. Alright guys, make sure that you've revised all of this, go back over it. Those of you that are in my classes will be doing some exam questions on it, and we've got a activity to do linked to greenhouses and selling greenhouses, believe it or not. Alright guys, thank you.